Okay, so guys, let's begin the permutation and combination section of A level CIE. Uh, I'm sorry, I'm wrong. It's CAIE, isn't it? Okay, so we will begin with. Wait, okay. So we will begin with October November 19 variant 62. Variant 62. So before starting, let me give you some basics. Like when you are operating with a whole group, isn't it? You are just choosing a group but not making any rearrangement between the elements of the group, then it has to be combination. But when you are rearranging the elements of a group, then it will be permutation. Or it's like that. For example, you have two or more groups together, and you are considering each group as a single element, and you are then making rearrangement between the elements. Then you are considering each group as an element, and you are rearranging between the elements. In that case, it would also be permutation. Okay. Now, okay, so let's go. Okay, and if two incidents are occurring together, then the permutations or combinations must be multiplied. And if two incidents are such that either this can happen or that can happen, then in that cases we have to add the permutations or combinations. Okay, so let's start from October November 19 variant 62. Question number 6. The height in meters of what? What's this? Okay. The height in meter of fir trees in large forest. No, no, no. I think I'm wrong. This is not permutation and combination. Okay. So question number 7. Find the number of different ways in which 9 letters of the word toadstool can be arranged so that all three O's are together and both T's are together. Okay, so three O's are together. They has to sit together. So we will consider the three O as a single element, and both T's are also together. So we will consider the two T's also as a single element. So 3 O's is equal to one element, and 2 T's is equal to one element, and all others are individual elements. Okay, so now let's go to solving. Okay, so it's TOADSTOOL. So how many O's are here? So 1 2 3, we 3 O's, this is one element, then 2 T's, these are another element. So 1 2 3 4 5, so 5 elements gone. We are left with 1 2 3 4. We are left with 4 more elements. Okay, we are left with 4 more elements, isn't it? Okay, so okay, so this is one element, this is one element, then we have 3 4 5 6. So A, D, A's and L, they are all different elements. Since they are they has to be kept individual because the question didn't said about grouping them together, isn't it? So we have total 1 2 3 4 5 6. We have 6 elements together that has to be arranged. So 6p6, which is factorial 6, which is 720. Okay, now let's go to question number 2. I mean 7 2. So what was the question? The question is, find the number of different ways in which the 9 letters of the word toadstool can be arranged so that T's are not together. Okay, T's are not together. That has to be the key point in this case. Okay, so in this kind of cases, like when you are solving cases like this, that something has to be together, okay, so if they are together, then just group them up and consider them as one element, like in these cases. But if they're not together, then what you will do, just look and learn. Okay, so T's are not allowed to stay together. There are 9 spaces: 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Oh, no, no, no. So I'm sorry. So we have OADSOOL, just eliminating the T's. Now write them. OADSOOL. Okay, so if T's are not allowed to sit together, then we have T's are not allowed to sit together, then we have these places: 1, 2, 3, 4, 5, 6, 7, 8. Okay, if T's sit in these places, then they will not be together. Okay, so we have 8 places, okay, where T's can sit, and we have 2 T's, so 8p2, but they are same, these 2 T's, so T is repeated. And in repeated cases, what we do is that we divide the whole permutation by the number of repeats, isn't it? Okay, so this is the arrangement for T. And at the same time, we can also rearrange the places of O, A, D, S, O, O, L, isn't it? So how many elements are here? 1, 2, 3, 4, 5, 6, 7. So we can arrange the 7. Oops, sorry. We can arrange the 7 elements in 7 factorial ways, or 7p7 ways. But here 3O are repeated, so it will be factorial 3, isn't it? So what would be the answer? The answer would be 23520. There are many other cases of like sitting not together, but we better not follow them because it's a good way and it's a shortcut way. You will get full marks, no problem about it. Okay, so let's go to number 3. Should we solve it because it's probability? Okay, let's go for it. No, I'm skipping question number 3. I'm going to question number 4. 5 letters are selected from 9 letters. Okay, 5 letters are selected from 9 letters of the word toadstool. Find the number of different selections if the 5 letters include at least 2 O and at least 1 T. Okay, so it can have more than 2 O's or more than 2 T's, but there must be 2 O's and 1 T present. Okay, let's go to solving. All right. Okay, so first of all, so we must have at okay, so we have to choose 5 letters. 5 letters we have to choose first. Make the possible selections. So if we take 2 O's and if we take 1 T, then we can take 2 other letters, isn't it? Okay, we can take any 2 other letters. Okay, so fixed we are taking 2 O's and 1 T's and 2 other letters rather than O and T. So we have how many choices here in this case? If okay, let me write TOADSTOOL. So if So I have taken two O's and I have fixed it. I have decided to take only two O's, but there are three O's and two T's. Okay, so there are how many other letters? There are four other letters. So from the four other letters I can take two letters. Okay, but now if I decide to take three O's, okay, three O's, and then one T, then I can take one other letter from the four. Okay, now what can we do is that oh, we can take two O's and two T's and one other letter from the four, these four others. And what can we do is that we can take three O's and two T's, that would give us five. So we will not take any letter from the four letters. So these are our possible, either this or this or this or this. So what can we do is, okay, so these are fixed that we are taking them, so we just have to choose from here. Just select these cases, the last cases. We just have to select, right? We didn't have to rearrange them, so it will go to combination. So it's 4C2 or 4C1 or 4C1 or 4 oops sorry or 4C0. That would give us total 15. Okay, so that's the end of October November 19 variant 62, the solving of permutations and combinations. Okay, now let's go to the next variant. Okay, so here we go. This is okay, October November 19 variant 63. Question number 2 is the permutation and combination. Okay, question number 2 variant 63. Okay, so let's begin. Okay, so how many different arrangements are there of the 9 letters in the word corridor? Corridor. Okay, let's see. So there are 9 letters. Now. Okay. So 9 letters are there. So we can arrange them in 9p9 or factorial 9 ways. But here we have, so oops, just wait. I'm sorry for the delay. Well, I'm actually sorry. Okay, so corridor, CORRIDOR, corridors. Okay, last year about AS লাগাইছি কি খারাপ এরা যাই হোক. Okay, oh, so I was talking English. Okay, so it's factorial 9 divided chala factorial 9 then divided by okay, so 1 2 3 3 r is repeated, so divide by factorial 3, and we have 2o repeated, so divide by factorial 2. That would give us in total 30240. Okay, so that's the case. Now let's go to the next question. This is question number 2, isn't it? Question number 2. This is 2-1. Now we're going to 2-2. So question number 2 said that How many different arrangements are there of the 9 letters in the word corridor in which first letter is D and okay, oh, the question, right? How many different arrangements are there of the 9 letters in the word corridors in which the first letter is D and the last letter is R or O? So it must include a D in the first position, and that means we have to multiply the letter R or letter O. So we don't have to bother about the position of D, because position of D has to be fixed, because D is always the first letter as the question is stated, and the last letter is either R or O. Okay, let's begin. Okay, so 1 2 3 4 5 6 7 8 9. Okay, so D is the first letter. Now let's think that it ends with R. Okay, so these two positions are fixed, so they are out of permutations. Okay, now we are left with 7 positions. We have taken one D, we have taken one R, so the we can take any of the R, but I prefer this one. I don't know why. So we are left with 2 more R and 2 O's. That means in total 7 letters, among which 2R and 2O are repeated. So it will be factorial 7 divided by factorial 2 into factorial 2, because 2R is more repeated here and 2O is repeated. Okay, now 1 2 3 4 5 6 7 8 9. Okay, as for example it ends with O. All right, ends with O, so it will be factorial 7. They're out of permutations, so factorial 7 divided by, if I'm taking O, okay, so the O is fixed, and so here one O will be present because another O is fixed here, and this is out of permutation. When you fix something, that is out of permutation. But here 3R will be repeated, so divide by factorial 3. So either this is the incident or that is the incident. So in total it will be factorial 7 into divided by factorial 2 into factorial 2, plus, since the question said or, so in factorial 7 divided by factorial 3. Okay, okay, so that is the case. Now let's go to question number 3 of the same year, because that is also permutation, or that may be the combination, I'm not sure. Let's see. A sports team of 7 people is to be chosen from 6 attackers, 5 midfielders, and 4 midfielders. Okay, the team must include at least 3 attackers and 2 defenders, and at least 2 defenders and at least 1 midfielder. Okay, so we have to just choose 7 people. So there is we just have to choose elements, not to rearrange the elements. So this has to be combination. Okay, so we got it ensured. All right. Okay, so how many different ways can the people of 7 be chosen? Okay, you must focus on the word list. At least 7 attackers, at least 2 defenders, and at least 1 midfielder. Okay, okay, so there are in total, what we have, let's see, we have 6 attackers, we have 5 defenders, and we have 4 midfielders. Okay, that is midfielder, please don't take it otherwise. So we have to choose 7, and it must include 3 attackers, it must include 2 defenders, at least, these are all at least, and it must include 1 midfielder. So these are the conditions given. All right, okay, So now let's, these are all at least, so you can take more than that but not less than these numbers. Okay, so what can we take? We can take, for example, 3 attackers, and then we are taking 2 defenders, and we are taking 3, no, 2 midfielders. 3 plus 2 5 plus 2 7. Okay, that makes 7. Okay, these are the given condition. Okay. Okay, we can take what? We can take like we can take 3 attackers, we can take 3 defenders. This is allowed, isn't it? It's more than 3. And we can take 1 midfielder. This is also allowed because the least value is 1. Okay, what can we take further? We can take like we can take 4 attackers, then 2 defenders and 1 midfielder. Okay, that is allowed. Do we have any more combinations? 4, if we take 3 that will make 7, but if we take 4 here and 3 here that will make 7. So no midfielders, but that is not allowed because we have to take 1 midfielder. Okay, so these are the just 3 combinations. Okay, now what can we do? For this one it will be 3 attackers from 6, so 6c3 into 2 defenders from 5, so 5c2 into 2 midfielders from 4, so 4c2. Similarly do it here and do it here, and since we can choose either this combination or this, so it's all or, so just add them together and your answer must be 2100. Still I'm doing it. It will be 6 attackers, 3 attackers from 6, so 6c3, 3 defenders from 5, so it will be 5c3, and 1 midfielder from 4, so it will be 4c1. Okay. Okay, and same goes for this. It's 6c4 into 5c2 into 4c1. That will give you 4200. No, sorry, it's 2600. I'm sorry, I'm really very sorry. Now let's go to the next question. The next question says the team that is chosen travels to a match in 2 cars. A group of 4 travel in 1 car and group of 3 travel in other car. How many different ways the team of 7 can be divided into a group of 4 and a group of 3? So car, which car is not mentioned, so it can be anything, just there are 2 cars. Okay, so 7, 4 will be in 1 car and so 3 will be in another car. So out of 7, for example, we are taking 4 in 1 car, so the rest of the 3 must be in another car. So out of 7 person we are taking 4%, and out of 3% we have to take all 3% in another car. All right, so this is the only one combination we have. There are no more combinations left, so here in this case the answer will be 35. Okay, so that's the end of measure 19 variant 63. Now let's go to variant 62. I'm pausing the video. Okay, so here we go. It's question number 6. Okay, find all okay, so it's October November 19 question paper 61, question number 6. Okay, find the number of different ways in which all 12 letters of word steeplechase can be arranged so that all 4 e's are together. Okay, all 4 e's are together, so e's must be all grouped together in a single and they appear as a single element. Okay, so e's are together. Okay, so let's do it. here is the camera. Okay, so staple case. So all four e's are together. So if we group all e's together as a single element, so four e's are here, we are left with 8 more letters, isn't it? So S T P L C H A S. Okay, so here are 8 letters and here are 4 e's which are all grouped together, so they appear as a single element, and here are more 8 elements, so we have in total now 9 elements. So 9 elements are grouped together, 9 elements are rearranged in factorial 9 ways or 9p9 ways, in which we have 1 2 okay s, so we have 2 s repeated, and we have s repeated, okay, t no, p no, l no. Okay, so this should be the answer, isn't it? All right, I'm sorry, just wait. Hope you can see, because the battery level has gone too low, so flashlight cannot be turned on. Okay, okay, so I have to turn on the room light. Just wait. Okay, so the answer would be 181440. Okay, okay, so now what to do? Now let's go back to the second question. The second question says that, well, find the number of different ways in which 12 letters of the word steeplechase can be arranged so that A's are not next to each other. Okay, so A's, the 4 A's are here, so they must not be next to each other, isn't it? Okay, so let's go to solving. Okay, so we have, instead of A's, what we have T E E P L E C H A E, isn't it? Steeplechase. So without 2 A's, there must be 10 letters. 1 2 3 4 5 6 7 8 9 10. Okay, so let me see how many spaces we have got between these letters. So 1 2 3 4 5 6 7 8 9 10 11. So total 11 spaces we have got to put S, and if we put S in these 11 spaces, then the S would not be beside each other. So for S we have 11 spaces where we can put the 2S, but since both of them are S repeated, so it would be factorial 2, and these 10 letters can be arranged, and so and we are giving multiplications in its, and we will arrange the A's and the 10 letters at the same time together. So these 10 letters can be arranged in factorial 10 ways, and in these 10 letters we have 1 2 3 4, 4 is repeated, so it will be factorial 4. That would give us 8316000. Okay, so this is how we have to deal with these cases. I hope you have got it. This is October November 19, the whole year permutation combination solve. So this is just a sample video. Now let's look, first you look at these videos, then let me see how much ideas of permutation and combination you get, then we will return again in our next video. And if you have any problem, please inform me through the comments. Okay, thank you.